So I believe that is recording. Welcome everybody to the August 26th free GMAT prep hour. My name is Reed Arnold. I'm excited to be working with you all today. Today's lesson it's kind of a, I always start with this. Today is a free 1 hour lesson. If you would like some other GMAT prep options, you can try a GMAT class, one of our first of our 9-session course. You can take the first one for free just to try it out, online or in person. So take a live GMAT class there or online. Yeah, and if you like it, sign on up. We also have private tutoring options. We want you to, we work hard to get you where you want to be. So if you're interested in tutoring, feel free to reach out to me after this session. If you have any questions, I'll be happy to answer anything that you're wondering about. Today's lesson, it's kind of I'm in a nebulous nebulous idea that I want to try out. And I want to talk about, on GMAT Quant, at least today, where difficulty lies in a question and how that should change in a way how you approach a problem and what you're kind of looking for and what you're kind of expecting and doing. Just out of curiosity, does anyone know what this picture, this weird picture is? I'm wondering if anybody will know this reference. It's probably a little obscure. No idea, says Eric. No idea, says Irene. This is a 3-dimensional map of the water temple from Ocarina of Time, video game from 96 or something. Legendarily difficult and the bane of my existence when I was about 8. And so when I was thinking of like what could represent difficulty, I thought of using the water temple because it is just such a legendary pain in the butt for kids trying to get through this game. So I want to talk today, we're going to do several problems and we're going to talk about what makes them hard. And I guess let's just start with one. I'm going to give you guys 2 minutes here to work through this word problem. Go ahead, give it your best shot. All right. And we will talk when the time is up. All right, friends, that's about 2:20. Go ahead, finish up if you think you're on a good path. one thing to always keep in mind on the GMAT is that sometimes you're going to have to guess and move on. If you have an answer for me, go ahead and enter it in the chat box. Be curious to see where we're falling. And if you're not sure, give me a question mark. It's totally fine too. Okay, so question mark C, question mark, question mark, question mark. Cool. So yeah, it's a tough problem. Okay, so a lot of question marks coming in. Just out of curiosity, what's hard about it? What would you say is hard about this question? Where do you feel like you're getting stuck? Yeah, Eric says he's having trouble setting it up. I get it. Anyone else? Same as Eric, maybe? How to separate one machine out of N machines when N is unknown. Good. Okay. I want to tell you all something about my own GMAT history. When I took this test, yeah, picking a starting point, the GMAT student named owner, according to the chat log. Owner says picking a starting point. It's hard to figure it out. When I took the GMAT myself a few years back, this was before I knew I was going to teach it or anything like that. I cannot tell you how bad I was at questions like this. These just threw me into a dizzy spin every time. I pretty much skipped them every time they would come up. And when one came up on the test, I skipped it. And pretty much, I tried to figure out for a minute and realized it wasn't going to work, and I guessed. And I think it's important that you all know you don't have to know everything on the test. You don't have to master every little subject and every little thing. You can have some weaknesses. It's okay. You just want to make sure your weaknesses don't cost you too much time and that you're not struggling to do a question that you're really not. It's not your vibe, right? Bail and move on. I was terrible at these. This question here, I don't think I would have had Snowball's chance in the hot place, as it's known. I don't know if I'm allowed to swear. Probably not. It's probably frowned upon. Is hell a swear word? Yeah, I said it anyway. I don't know if I could have done this. It's a very tough question. It's hard to set up. I have N machines and I need to know one machines, and there's a lot of difficulty here. Okay, just a big GMAT thing to be aware of. When you see answer choices like this, do you know what that means you should maybe consider doing? And what I mean by that, when you see answer choices with letters in them, what that often means you can do. Yeah, good. Eric says smart numbers, and that's exactly right. You can pick your own numbers for the problem. And very often when you have variables in the answer choices, it's a pretty good thing to do. It often makes it a little bit easier. But even if you know to do that, this question is still really tough. And I call this, I just call this conceptual difficulty, which is, you're probably mad, like, Reed, we know it. We know that concepts are hard on the GMAT, but again, we'll see several types of difficulty today. And I think conceptual difficulty is the one that, hurts the most maybe, because it's just like, God, I don't even know what to do. And it will always happen. It's a very subjective type of difficulty, right? Because for some people, this question might have been easier if they're familiar with this concept. For some people, it might not have been. But everyone is going to hit something where just the concept of the question is just hard. It's just a tough, like, I don't even know what to do. The particular concept being tested here, it's a work rate time question, okay? And so when we're doing a work rate time question, we want to deal with kind of the standard work rate time equation, work equals rate times time. I'll show you all how to do this two ways, once with algebra and once picking smart numbers. And I think picking smart numbers will probably show you why it's kind of a nice thing to do. So we're doing a work rate time equation, but the question is, like, well, how do I handle these multiple machines, right? That's kind of the concept that's making this standard equation, right? We're used to work rate and time. But once we have multiple machines, the concept gets more complicated. And if you're not sure how to handle that conceptually, you're just probably not going to get this question right. It's just too tough. But there's just a fundamental a fundamental concept to keep in mind when you see questions like this. When you see things working together on the GMAT, you can add the rates. That's kind of the concept that shows up over and over and over again on GMAT rate work together questions. Okay, and that's what's happening here. I have these machines working together. The work that they're doing P units at first. Well, I don't know how many machines I have. It's N. All right, but if I add the rates of each machine, since it's an identical rate, I guess, I didn't actually specify that it was an identical rate. Forgive me. I made up this question and didn't specify that. But if it's an identical rate, I can add that rate N times. And N time, if I add something together N times, I multiply N times R. And it takes them 6 hours to do this. Okay. Well, with this, I can solve for the rate of one machine. That's what R stands for me, the rate of one machine added up in times here, okay? So if I solve for that individual rate, it's P over 6N equals the individual rate. And I want to take that individual rate, I'm going to come over here to my white page. I want to take that individual rate and figure out how long it's going to take one machine to make 400 units. And it's still using the standard work equals rate time equation. Okay, so 400 equals the rate of now one machine, P over 6N. Okay, and I don't know what the time is. That's what I'm trying to solve for T. Well, if I solve for T, I multiply 6 times 400 is 2400. And then I'm multiplying by the inverse of the rate here. So I multiply 6 times 400, and I'm multiply by N, and I divide by P, and that equals time. Okay, so the answer here is D. All right, now once you know the concept, once you get this set up right, because you know to add rates, and once you solve for that rate and plug it back into a different work rate time equation, because it's a different scenario now, the work you'll see is not horribly difficult. But if you don't know that concept, if you're not familiar with that, if you haven't practiced it, it really comes off, really, really tough. And there's no point banging your head against the wall. Guess and move on. All right. Are there any questions right now about this way of doing the question, this particular work through? Anything I can help you with? Any part that's not clear? Owners at yes, there is a question, or yes, we're good to go. How is rate equal to N and R? It's equal to P over 6N. So if I set up my rate equation, okay, if I set up my rate equation here with the units I have, and I solve for the individual rate, where R is the individual rate, I divide by 6 and I divide by N, and that gets me P over 6N. It isolates the R. Okay, and the way I set up this equation was by adding the rates together. The rates of each individual machine. Each individual machine has a rate of R. I don't know what it is, because that's what I'm going to solve for. Each individual machine has a rate of R, and I know I can add the rates together when they're working together, so I add R plus R plus R plus R. I don't know how many times, though. Eventually I do it N times. There are N units of R, which equals N times R. Okay, kind of an ugly R there, but, and I use that standard, I plug that into the standard work rate time equation, solve for R, plug it back in, okay. You can also do this, I'll show you quickly, by picking smart numbers, all right. And you want to be smart about the numbers you pick. I have, this, again, I'm doing standard work rate time equation. I'm going to say, I know the T is going to be 6. I'm given that. I don't know how many machines I have. I know eventually I'm going to deal with this 400. Okay. But I know I'm going to have to divide by 6. I have a rate that I'm going to solve for. I'm going to have to divide by 6 to get the rate. So I want some numbers that are going to divide nicely by 6, and maybe you're going to be nice with 400. And I think P equals 600 is a decent choice here. There are many others, but 600 here. and I want it to divide nicely, so I'm going to put 10 machines. I'm going to say I have 10 machines. Okay, so N is 10, P is 600, and then I just divide by 60 on both sides. This 10 times 6 is 60, and I'm left with the rate of one machine is 10. Okay, well, I plug that into the 400 equation. 400 equals rate, which I now know is 10, times the time I'm solving for, and I just divide by 10, and time is now 40. Okay, and so I plug 610 into these answer choices and see which one gives me 40. Okay, and I don't have to do all the math here. I want to be clear on that. Like, I don't need to do anything on A, because 2400 times 600 times 10 is huge. It's not 40, right? That's a big number. Okay, B, 2400 over 600 times 10. Well, that's over 6,000. I don't need to figure out what that is. It's not 40, because this is a fraction that's less than 1. So when you're plugging in the answers in, use estimation, use approximation, use some high awareness to not have to do all the arithmetic. Okay, and you're going to find the only one that actually gives you 40 is D. Okay, and that's picking smart numbers, and it saves you kind of having to deal with those variables, which tend to throw people off. All right, but where's the difficulty here? It's in recognizing the concept. It's in recognizing that the concept here is tough. And you have to just keep this in mind, that they're always going to be able to throw that at you, and you need to be ready to bail. Okay, some signs that you're dealing with conceptual difficulties, you know, just ask a hard question. If you're not sure where to begin, okay, that's often that you don't understand this concept well enough, right? So recognize that thought, like, I don't even know where to start. Okay, by question. I'll come back to you in a few weeks after I've studied up, okay? Or maybe never, because again, I'm terrible at work rate time questions. Who cares, right? You're allowed to have a few weaknesses and still get a great score. Again, this is subjective. Something that is conceptually difficult for one student isn't for another, and something that is for you now won't be later, but it's always going to be there. You have to understand and build deeper understanding of these concepts and learn these little rules, these little, I call them knock-knock jokes. I stole that from another teacher because the GMAT will give you a knock-knock, and you give the who's there, and that's like the response to do. And one thing to keep in mind is also know what's not a concept, right? A lot of people see something like this, 9x squared over the square root of 9x squared plus 16y squared, and they want to say, oh, that's 3x plus 4y. But that's not the concept. That's not a rule of math. You can't square root x plus y and say that that's root x plus root y. That's poor understanding of the mathematical mechanics of the GMAT tests, because that's not allowed. It's not true. All right. So get your concepts down, and whenever you come across a question that tests you this way, skip it if it's a real test or the practice test, and then review it deeply and figure out what concept's going on and figure out what you're supposed to do. All right. I'm going to skip this one. We might come back to it if we have time, but I want to make sure I get through all the types of difficulties first, and then we can do other versions of the same questions. Take a look here. I want you to do, try to do both of these. Okay, try to do both of these. I'll give you all 4 minutes, and then we will talk. All right, friends, that's about 4 minutes. Go ahead. I see some people have already done this, but go ahead, put in your answer for the first question and a question mark if you're not sure. We'll do this one at a time. We'll do the first one first. Okay, I got a call for B. I got some C's. I got some E's. What do we think about this first question here? E. C. Okay, C. Cool. Okay, so let's talk about this. I'm gonna, for the sake of time, I'm gonna kind of, because there's so much to talk about and I always run out. I call these questions, presentationally difficult. And there's a very thin line between conceptually difficult questions and presentationally difficult questions. And I would actually say that what starts as conceptual difficulty, as you start to better understand the concept, eventually becomes presentational difficulty. So this is kind of going to be a lot of overlap. And this is true about all these types of difficulty. They can overlap in the same question, right? Presentational difficulty, I think, occurs in two ways. One is like this first question up here. How many factors do n and n plus 4 have in common? I feel like that's just a very vague question. It seems almost impossibly vague at first pass through, and it's kind of unusual. Maybe it's a little unexpected. And I think usually there's a sign like, hey, do some investigating on this, because it just seems a little murky and like random almost. And then it's the more common, probably, example of this. Ben, I will not be discussing verbal questions tonight. Every one of these kind of has a topic that we choose as instructors. Some of them have been verbal. I did a critical reasoning one a few times ago, so you can look in our history if you're looking for verbal. Today will be strictly quant, although I would like to do this for verbal at some point, because I do think it is valuable. So I think presentational difficulty has the kind of the vague, murky question, or like the one that just is clearly like gross looking, right? Whenever you see a question that looks gross, it's very likely, not always, but it's very likely presentationally difficult. The difficulty is how you handle this question that just seems either vague or gross. And this first one up here, how many factors do n and n plus 4 have in common? We'll do some investigating. You know, every number has the factor 1 in common, right? Because that's the factor of all integers. But if you pick like 3, okay, well, if I pick 3 plus 4 is 7, what factors do they have in common? None. They have no factors in common, okay? How many factors do 5 and 9 have in common? None, okay? That's interesting. How many factors do 15 and 19 have in common? None. And maybe you start to realize, hold up, if I add 4, I'm at 2 odd numbers. Okay, and 2 odd numbers they can have common. 2 odd numbers can have common factors, but 2 odd numbers that are only 4 apart, they never seem to really have any factors in common. 23 and 27, none. Yeah, I'm just never going to get a common factor here. Okay, so if n is odd, I guess the answer is, well, I'm sorry, I've been saying none. 1 common factor, excuse me. They have 1 common factor. 1 itself is the only common factor. Okay. Well, if I pick some even numbers, how about 2 and 6? How many common factors do they have? They have 2. They have 2 common factors, 1 and 2. How about 4 and 8? Well, they have 3 common factors, 1, 2, and 4. 12 and 16. Well, they have 2 common factors. No, excuse me, 3 common factors, 1, 2, and 4. How about 10 and 14? Well, they only have 2, 1 and 2. And you might start to realize that really what's going on here is if it's even, if it's not a multiple of 4, if n is not a multiple of 4, you're going to only have 2 common factors, 1 and 2. And if it is a multiple of 4, you're going to have 3 common factors, 1, 2, and 4. Those are the only possibilities when integers are only separated by 4. Okay, and there is a deep conceptual difficulty to this that you could understand and will wrestle with as you study for the GMAT. But even if you have no idea what that is, even if you have no idea what the underlying math is, just by investigating the question, you can find a pattern that makes the question a little clearer. You're really asking, is n odd, or is it a multiple of 2 or 4? Those are the is it a multiple of 2 and not 4, or a multiple of 4? That's really what's being asked. okay? And when you go to the statement, statement 1 tells you it's even, so that gets rid of all this, but we're not sure about 2 and 4. Okay, well, statement 2 tells us n is a perfect square, but it doesn't tell us if it's even or odd, so that's not enough. Now, if we combine the two, perfect square seems kind of random, but we already tested 1 with n, 4. We could also test, okay, it's an even perfect square. How about 16? Well, 16 plus 4 is 20. That gives me, so it's a multiple of 4, so that gives me 3 common factors. Another even perfect square is 36. 36 is a multiple of 4. 100 is a perfect square that's even. It's a multiple of 4. Oh, wait, I wonder if every even square is a multiple of 4. It is. And even if you don't know that, you can figure it out just by doing the investigating, if you know what to look for. So when a question kind of seems vague, do some poking around. Do some investigating. It'll help clarify it for you. You can work through it that way. Okay. This second question down here, okay, looks gross, looks really hellish. Might not be sure how to simplify that. Go ahead, plug in your answers for this second question. I'm curious where we fell here. Lena says B. Christina says B. Thea says B. So I'm sorry, thank you. I never specified. The answer to the first one is C. By using the 2 together, I know that n is a multiple of 4, which tells me what I need to know about n and n plus 4. I have 3 common factors. So, okay, down to the second one, a lot of B's coming in, which is good. Okay, how do you simplify this? Well, it's presentationally difficult. You have to look for some way to simplify the presentation. And you might notice a relationship between 11 and 121. 121 is 11 squared. So I have 11 squared x, and 49 is 7 squared x. Or 7 squared y, excuse me. And then I have 11 to the x and 7 to the y. And now you might recognize that what's going on up top, this 11 squared x, that's also 11x squared. I can rewrite that if I want. 11x squared. I can rearrange the 2 exponents. Minus 7 to the y squared. Over 11 to the x plus 7 to the y. And now this actually looks like a much more standard GMAT game. Okay. We might have seen it before in more generic terms. A squared minus b squared equals a plus b times a minus b. It's a difference of squares. It's one of the GMAT's favorite things to do. And when I have something in the difference of squares format, I can just break it up into the other form. If I have this form, I go to this form. If I have this form, I go to that form. It's almost a reflex. Again, not jokes. Okay, so I can turn this one up here, even though it doesn't look like what I'm used to. Once I've simplified the appearance a little bit, it actually just breaks up into 11 to the x plus 7 to the y times 11 to the x minus 7 to the y. Okay, all over 11 to the x plus 7 to the y, and that is going to cancel. I'm going to cancel it for the sake of time. That just can't, the denominator goes away, and I'm left with just 11 to the x minus 7 to the y. Okay? It was, the GMAT is hiding a very familiar concept, probably, if you've been studying for the GMAT for, you know, a month or so. You've definitely come across a difference of squares. A lot of people make flashcards for them, right? Something you've seen before. They hide it in a weird appearance, and that's something they do a lot. So when something looks gross, there's often actually a sneaky, nice thing underneath it if you are looking for the right things. And, you know, look for common squares. That's a nice thing to use for quadratics, a number and the square of the number. Know your exponent rules. Use your exponent rules to make things nicer. Okay. And again, these are conceptually difficult as well. There's a lot of overlap between them. But what starts as conceptual difficulty often becomes the difficulty in appearance. All right. And find a way to make it simpler. Okay, it's funny, the ones that are presentationally difficult are often not that challenging if you see through the presentation. All right, we'll see some later that actually present easy. They look easy and they're actually not, they're hard. It's a funny, mean game that GMAT plays. If it looks easy, it's difficult. If it looks difficult, then it's probably actually be easy. So when something looks nasty or very vague, if you have that first like, oh God, ugh, if that's the impulse, okay? Look to simplify. Know your knock-knock jokes. Know what to look for and what to do when you notice certain things. And again, know those rules and processes. I mentioned here, don't memorize formulas, right? The difference of squares formulas, a lot of people memorize it like, okay, a squared minus b squared is a plus b times a minus b. They know that like the back of their hand, but they don't know what it means. So when it shows up in a way that's presentationally different, like the one we just used, they don't recognize that they can use this, right? And so don't just memorize a squared minus b squared is a plus b times a minus b. That's memorization of letters and words, right? That's not so good. Get the process down, okay? When I see, did I write this out wrong? Oh, I'm sorry, I used a different formula. I used a plus b squared, another commonly tested quadratic. Okay, you can memorize what a plus b squared is, a squared plus 2ab plus b squared, all right? But don't memorize just the letters. If I see two things added together and squared, I know I square the first thing, I add 2 times the product, and then I add the square of the second thing. Know what you're gonna do, not the letters. The letters won't stick, they're not transferable, okay? So take a look at one more, I think, presentationally difficult question. Take 2 minutes for it. And we'll move to the next type. All right, okay, oops, drop my stopwatch. There, you have a few options on how to do this. There's a lot of ways to change the appearance in a way that's nicer for you. They're all gonna use exponent rules, which you need to, again, get that concept down. But if you use your exponent rules, okay, 1/5 to the m, I can say that's 5 to the minus m. That's what a negative exponent is. And you can turn it into a fraction. Same thing with 4, I can say that's 4 to the 18. Okay, and then I can say that equals, well, 2 to the negative 1, because 2 to the negative 1 puts it in the denominator, 10 to the negative 35. Okay. Well, exponents, whenever I see a bunch of exponents in a question, in an expression or an equation like this, it's a knock-knock joke, and the thing to do is find common bases. Okay, boil these down often to the primes. Okay, so I'm going to call 5 as prime, so it's 5 to the minus m still. Oh, and that should be minus 18, excuse me, for the 4. Well, 4 to the minus 18, that's 2 to the minus 36, if I know my exponent rules, because 4 is 2 squared, and 2 squared to the minus 18 is minus 36. This is 2 to the minus 1, and my 10, I'm going to break down 2 times 5, to the minus 35. Okay, my left side is going to stay like that the whole time, and I'm going to distribute, because I know my exponent rules, I can distribute that minus 35 over to the other two numbers in this parentheses. That's 2 to the minus 35 times 5 to the minus 35. Okay, well, the 2 to the minus 1 and 2, that becomes, I can add my exponents, 2 to the minus 36. And that cancels out both sides of the equation. I can divide 2 to the minus 36 or multiply 2 to the 36. Either way, it gets rid of it. And I'm left with 5 to the minus n equals 5 to the minus 35. And I can now get rid of the 5's, and I'm left with minus m is minus 35. So m is 35. Using exponent rules and changing this, I mean, that's just gross. Blech. Heinous, heinous, gross. Okay, make it nicer. Change the appearance. Use the exponent rules, make it nicer. Okay, just presentationally difficult, and again, conceptually difficult if you need to practice your exponent rules. There's a lot of overlap there. Okay, any questions that I can answer here before we move on? Speak now, forever hold your peace. Cool, all right. Moving on up. Clear all the drawings. Take 2 minutes. And you know what, I'm just going to share the question screen. I think that'll be easier to see. Okay, cool, okay. Take a look at this one, 2 minutes here. That is 2 minutes. Start trickling into a final guess here. Okay. Go ahead and feel free to throw up question marks if you don't have, I'm just gonna have to guess kind of randomly. Or if you have maybe an educated guess, you could put a letter and a question mark, like C, question mark. And I have A's and E's, which is a little unexpected. Amani gives a soft E, an E, question mark. Okay, so we're split between A's and E's, which is curious. A B question mark. Okay. So here's the, I guess my question is go ahead and type in the chat. Did this seem, as I intended it to, did this seem quite a bit easier than other questions? Go ahead and tell me if that seemed, do you agree with that this was easier than other questions? See a lot of yeses. Okay. And I think it should be, and it should feel easier than other questions. Now, the trap I thought I had laid was not snared, so you all did very well to avoid it. Congratulations. Many people answered D on a question like this. D is a very common answer because a lot of people say that statement 2 is sufficient, right? We'll talk about why. This question I call secretly difficult. This is not the same as, evidently, pretty clearly up front, not the same as what we've been dealing with, right? You don't read it, you're not like immediately bamboozled. It doesn't intimidate you with a bizarre appearance and a gross fraction with a bunch of exponents or weird numbers. Kind of a straightforward question. We have a range for x, it's an integer, and we want to know is it prime. And then we have this thing about being prime and this thing about being a multiple of 5, and it's all pretty straightforward stuff. I do want you all to think about this. Why would someone, especially those of you that chose A, because that's great, why do you think many people say statement 2 is sufficient? See if someone can pinpoint that. Why would someone say statement 2 is sufficient? If you realize it was not, if you chose A, what's the game that's being played here? And this is inspired, by the way, directly from a question from the book that plays a similar game and snares a lot of people. I can't use the exact questions for copyright purposes, but figured I'd make one similar. Has anyone figured out why this would be difficult? Quote unquote, even though the person who did it did not probably think it was difficult. So I know that these possible, okay, so there's, 26, 27, 28, 29, 30, 27. Yeah, Lina, that is correct. That is why statement 2 is not sufficient. But why would someone say it is sufficient? Why would that be an actually pretty common trap answer here? All right. These are the possible values of x, 26, 27, 28, 29, 30. Statement 1 tells me that x minus 2 is a prime number. Okay, well, if we go through our options here, the only one that fits that is 31. That's the only number that minus 2 is a prime number. Okay, and so that means is x prime? Yes, it is, because x is 31. So statement 1 is sufficient. So I know I'm down to A or D. I cross off B, C, E. Okay. Statement 2 gives me x minus 1 as a multiple of 5. All right. And here's where people sometimes slip up. They already know they have 31 on their brain because they did statement 1. And then they think, okay, x minus 1 is a multiple of 5. Well, 30 minus 1 is 30. That follows the rules, and great. So x could be 31, which I know it is. And then they do 26, and they say 26 minus 1 is 25. But then they think, but 25 isn't allowed. It's outside the range. And so it's not allowed. So I can't use 26. Or I can't use 26. So the answer is sufficient because it tells me it's 31 again. Answer D. But that's a mistake because this 26, when I subtracted 1 and got 25, yes, 25 is not allowed, but it's not allowed for x. It's perfectly fine for x minus 1. But if someone is rushing, all right, if they're rushing too fast and they apply the constraint, this range, if they apply it to the wrong thing, it's applied to x, but if they apply it to x minus 1, they miss that 26 is actually a possibility. And they say that it's sufficient because the only one left would be 31. All right. These are the types of questions that you'll often say are a trap or a trick, right? Oh, the GMAT tricked me. And I really discourage, me and another teacher, we wrestle on whether or not this is true or not. I discourage saying the GMAT tricked me because I think that gives the GMAT too much power. I think, you realize like, I missed something. I can fix that. That is something that's in my power to fix. And I think it's encouraging to say the GMAT didn't trick you. You just did something wrong. The GMAT will prime you to use biases, to bias yourself against certain possibilities, to make little cognitive mistakes like this. All right. And these last two types of difficulties, secretly difficult and the one we're going to do next, these are the ones I really want to focus on tonight, because these are the ones that I think, conceptual difficulty, you got to wrestle for that. You got to, stretch your brain, learn this new stuff, and it can be tough. Throw your book across the wall, frustrating sometimes. These last two are much more habit-based, and in a way that's easier to fix, and in a way it's harder to fix. But it is definitely fixable. And to get through most of the 600 level questions, you need to get through these two types of difficulties. And this one is the secretly difficult. Okay. Signs that we're in secret difficulties: if it seems fairly straightforward, if it seems like pretty clear, great, I know how to do this, that's actually a sign to be a little cautious. It might be trickier than you think it is. Remember, the ones that seem difficult are often easy when you get through it. The ones that seem straightforward are the ones you need to be careful on. When things jump out at you almost immediately, okay, slow down. Make sure you've made a good thought there, right? Make sure you've actually connected the dots correctly. All these questions, they rely on you making an incorrect or unsupported assumption. Okay, they hit cognitive blind spots like confirmation bias. I know it's 31. Statement 2, great, tells me 31. 26 is impossible. Hold up, slow down. 26 is possible. You're hitting a blind spot there. I do think they're somewhat more common on DS than PS, but it shows up in both. Okay, and you just need to practice care and slow down and really think through the process. All right. If something seems easy, maybe it is, but don't let up. In fact, be more attentive. Make sure you're really not overlooking something or not jumping to a conclusion that's unsupported. Okay. If we have time, I would like to do one more quant question in this realm, this one right here. Actually, here's what I'll do for the sake of time. I want you all to read this question. Just take 30 seconds or so, and I just want you to tell me the answer that is the trap. Oh, I made an unsupported assumption answer, the one that jumps out at people, the one that people answer without fully thinking through. See if you can pinpoint that in 30 seconds or so. Don't try to do the question. Okay, so that's a minute. Let's just talk about this. I don't want to go over answers and whatnot. And again, this overlaps with conceptual difficulty. All these things can kind of interweave, but this is a fairly straightforward question. We have an isosceles right triangle, and I know the GMAT loves those, and I know that they have these proportions of side lengths, x, x, x rad 2. Okay, and so I know that the hypotenuse is almost always something times rad 2. And I know that this is the perimeter. If I add up the sides, it's 2x plus x rad 2. And it's like, okay, cool. Here's the hypotenuse. Great, 16 rad 2, because that's what I usually see. And so I choose E. And that's not correct. That's actually not the answer here. I think those of you that were answering, hopefully you were answering, a lot of people answered E. I hope you were answering for this as the trap, as I asked, and not for the one that was correct, because this is exactly the trap that they've set for you. They expect people, especially people who have studied well, like, oh yeah, hypotenuses are usually something rad 2, 4 rad 2, 2 rad 2, 8 rad 2, 16 rad 2. And they expect you to be like, ah, great, well, that's the hypotenuse, because the hypotenuse is the thing that has the rad 2 in it. All right. And so 16 rad 2 is a big trap answer on this question. And it jumps out at you really quickly if you're fairly familiar with right triangles. But it is a trap. I will leave it to you all to do at home find the actual right answer. I will give you a hint. The algebra is actually kind of gross, and it might be easier to start with the answer choices and work from there. That might be a useful idea of back solving. Okay, so let's do at least one more question. I know we're already towards the end of time. It always goes so fast. But I'm going to do one more question and talk about one more type of difficulty. Okay, so I'm going to give you all 2 minutes. Here we go. 2 minutes, begin. All right, start filtering in your final answers, especially because we're running out of time. Any answers here, friends? Call for A. Calls for D, got some Ds. Okay, cool. Where's the difficulty on this question? What makes this question hard? Because it is hard. Christine, a lot to keep track of. I agree with that. I suspect that's what many of you are kind of feeling. There's just a lot to keep track of. There's a lot of moving parts. There's a lot of relationships, a lot of fractions, a lot of information. Okay, there's a lot of information here. And this is probably a 700 level question, but I find personally that many 600 level questions are harder for me than 700 level questions, because a lot of 700 level questions are what we have talked about tonight, conceptually difficult. But once you understand the concepts, those are really not that hard. But a lot of 600 level questions are in this vein of difficulty, and nothing here, if you really read it, Nothing here is conceptually bizarre, I suspect. We have a number of bags, we have fractions of marbles, but nothing it's like, what? What is that? I don't know what that is. Like, we know what a fraction is. We know conceptually everything here. It's the organization and the abundance of information that makes this problem difficult. And I call this an organizationally difficult question. Nothing about it is probably conceptually rough. It's all in the organization, and it's all in the setup. And I did a question like this with a student a few weeks ago, and that's kind of this is one of the things that's prompted me to think about this kind of stuff. We were doing this question, and I looked over, I was working on it, and I read it, and I was like, man, that is a doozy of a setup, right? Not conceptually hard, but man, there's a lot there. And so I was working really carefully to get everything organized and to set it up well. And I looked over at him. It took me about a minute and a half to feel comfortable that I had set it up right. And at that point, I looked to see his work, and he was like almost finished, quote unquote, almost done with the question. But I could tell immediately that he was in real trouble because his setup was not correct. And so he was doing all this math and all this algebra, and his answer was not going to be there because he'd set it up wrong. The numbers were not working out nicely because he'd set it up wrong. And so it was just like, he's dead. He's almost done, but he's toast. Meanwhile, I had just started, quote unquote, and then I took 30 seconds to work through the math and I was done. Why? Because I spent a minute and a half setting it up. And I turned to him and I was like, hey man, this was after he was done. I was like, where's the difficulty here? Why was this question hard? And he kind of looked at it and he said, I don't know, the setup. And I said, you're exactly right. Why were you almost done with the question when I had only just finished setting it up? And I realized that I think there's, a fear of spending time setting up a problem right, when really that is the problem on a question like this. They are testing you on your ability to set up and organize, not on your ability to work through algebraic equations and solving for x, whatever. It's a reading comp question in math. And so when you see a question like this that's not conceptually difficult, give yourself the freedom to work a little more slowly on the setup. Figure out how you're going to set it up, okay? First thing I notice here is that everything here is relative, except for the number of bags. But I don't know anything about the total number of marbles because I don't know how many marbles are in each bag. I have fractions of totals, but no actual totals, which is another sign that I can pick smart numbers, okay? Well, I have 8 bags that have the same number of marbles each, and then I have this 9th bag over here. So here are my 8 bags, and over here is my 9th bag, okay? And it says each of the 8 bags holds the same amount, and this one holds 2 times that amount. And in the 8 bags, 1/4 of the marbles are red. So I want to pick a number that's a nice multiple of 4. So why not say each of these 8 bags has 4 marbles, and 1/4 of them, 1, is red. And then I know that the 9th bag holds 2 times the amount of marbles that each of the other bags holds. And I have to be really careful about these comparisons. 2 times as much as each of the other bags, not 2 times the total of the bags. If you do that, you're in trouble. The words are very specific. So spend time reading the words and pinpointing what's going on. And this 9th bag, he puts X times as many red marbles in as he puts in the other 8 bags. I don't know what that is, but it's 1 times X, or just X. So he's put X marbles in this 9th bag, okay, that holds 8 total. And over here, these 8 bags, I know I have 32 total marbles, because 8 times 4 is 32, and 8 of them are red. And in this 9th bag, I have 8 marbles, and X of them are red. And so total, I have 40 marbles. That's the 32 and the 8. And I know that 3/8 of the marbles of the total marbles are red, and 3/8 of 40 is 15. So I know I have 15 marbles that are red. Okay, 3/8. So I have 15 marbles that are red. Well, 8 of them came here, and then that leaves 7 to be found here. So X has got to be 7. And so that's the answer here. It's not conceptually difficult, really. There's, nothing here is, I don't have to teach deep number properties or anything like that. It's just reading carefully and setting up the problem right. And I've found that students are afraid to spend time up front to work through a question and make sure they've figured out how to organize the information. All right. So when you see a question like this, and here are some signs that you're dealing with organizational difficulty, you know, it's a lot of words. There's long word problems. You have a lot of relationships to keep track of. There's nothing that's strange. It's just overwhelming, right? And then, you know, that means spend time on the setup and on the question. Give yourself permission to do so, because that is what you're going to be dealing with. All right. So it's basically tedium, right? So if a question looks easy, it's probably sneakily hard. If a question looks hard, very often there's a little way to change the appearance to make it easy. If a question looks tedious, it's probably tedious. But spend time on the setup working through that tedium, and often the numbers will work out nicely. Okay, so I'm afraid we don't have time to do some of the other questions I had that fit these categories, but I want you to keep them in mind as you're studying. You know, is something conceptually difficult? Just like, man, that's really hard. I don't know if I've fully understood that. Is it, what's the other term I used? Not organizationally. Secretly difficult. Presentationally. So is it conceptually difficult? It actually, you know, makes you rack your brain. Is it presentationally difficult? It just looks hard, and there's a little sneaky way to simplify it. Is it secretly difficult? Look straightforward. Watch out for traps. Make sure you're not making unsupported jumps. Or is it organizationally difficult? Do you just need to spend time setting it up and on the question, understanding it? All right. I will stick around now for any questions you all have, but I hope this was useful and as fun as one of these things can be. You will not be sent a recording of this, but it will be on YouTube. So you can find our YouTube channel, and all of these free GMAT prep hours are up there. So this will be posted here in a few days. So you can redo all the questions and whatnot. Otherwise, I'll answer any questions once this recording is stopped. I hope this was useful, and I look forward to seeing you all at the next one. Have a good night. Best of luck in your studies. All right.